Well, it's a new week here in the Red Eye Garage, and I have an exciting new series of videos coming up. Right in front of me is a beautiful powder-coated Dana 44 out of Mike's CJ3B. So this came right from Kaiser Willys, and I have the honor of reassembling it and replacing a bunch of parts. They have it stripped down and powder-coated, but we're going to be rebuilding it. And installing a lot of new old stock and American-made parts from Kaiser Willys. So buckle up. I don't know what's going on in here, but it's going to be like a brand new axle when we're done. I'm going to follow this video series up with a Dana 25 series doing the same things. So first step is going to be to kind of assess the parts we have and get the tools around, pop this cover off, see what's going on inside. Going to replace all the bearings, seals, run a pattern on the gears, make sure everything's good, and get this thing crated up and back to South Carolina so that Mike and Jason can continue the restoration of the Kaiser Willys CJ3B. As I get started on this project, I have a fresh pad of note paper and a pen to kind of take an inventory and also to measure and write down any shim sizes, bearings that we remove, things like that. Then I popped open this box, and lo and behold, the glory within. We have some new old stock parts here. These were packaged in September of '85 by Lefty Auto Parts. So that's one of the things, great things about Kaiser Willys is they work really hard to make sure they have the best parts possible to get to you. So these are new old stock wheel seals or axle seals. And then as you can see back here, a beautiful row of Timken bearings. So these are, I know there's a lot in here, but we're doing a 25 and a 44. So, you know, and then all the little small parts too. So we're putting new vent, new inner axle seals, and then there's the shims and oil slingers as we set up the bearings, and all the spacers and gaskets for the outer seals. So just really good parts, one-stop shop. And as we get into this project, we'll pop these babies open, and this thing will be spinning like new in no time. As with any project, before we can rebuild, we gotta disassemble it. So I'm gonna pop the cover off. We'll see what's inside here. I hate even putting a socket on these powder-coated bolts, but we gotta open it up. One of the most scary but exciting parts is cracking it open. I don't know anything about this axle, but you're seeing it for the first time right along with me. Okay, well, it's got a lot of gear marking compound on it, so I'm not sure what that's all about, but thankfully it doesn't appear to be full of rust. It turns over really hard, so I don't know if someone attempted to set up the preload on the pinion, but gears look good. So I'll pull the carrier out, and we'll see what's going on inside. I got everything freed up, so it's spinning nice and smooth now. Just got some oil down in the bearings. So what I'm going to do now is, I don't know what all this gear marking compound is, but I'm going to put some fresh compound on there and run a pattern and just see what's actually going on before we tear it apart. That'll help us with the setup and installing the shims, just to kind of have a baseline. This stuff's kind of like anti-seize. It gets everywhere, and you don't need anywhere near as much as what you're seeing in here. I usually just come in with a little blob, a little packet the size of like a McDonald's ketchup packet is plenty. I do both sides of 3 or 4 teeth. That's all you need. It doesn't need to be a big mess all over the whole carrier like this. The way I like to do this is I take a drill or an impact gun on the pinion nut, and then I take a leather glove, and you have to put some resistance on the ring gear, otherwise you won't really get a good pattern. So I'm squeezing with the glove. The more resistance you can put on it, the better your pattern will come out, the more readable your pattern will come out. Okay, go one direction, switch sides and then go the other. You want to put it on the side it's moving away from, otherwise it'll suck your glove into the case, and we don't want that. Because we want to get a drive and a coast pattern. And don't worry, there's oil, enough grease and oil on these bearings. We're not damaging anything by using the drill. It's a little tricky to get you in there nice and close to see this. But the pattern really isn't too bad. It's pretty even contact all the way across on both sides. So I'm going to take some pictures of that for reference, and then we'll take everything apart and we'll measure and document the shims and where they were, but now we kind of know what it looks like before we start, and that will help with the reassembly. Alright, so to remove the carrier, just take an impact gun. These are 3/4 inch socket for these nuts, or these bolts, and then remove the caps. Sometimes you have to give them a whack. Usually they pop right out. And I like to keep a piece of cardboard nearby and set them in the exact orientation they came out so you can see the numbers. It also pays to maybe take a picture because you don't want to mix these up. Now on to removing the carrier. If your axle is in your vehicle, just be careful. Sometimes when you pull those caps, the whole carrier will fall right out, and it weighs about 20 pounds. You don't want it smashing your toe. You also don't want to drop these teeth on your concrete shop floor or in the dirt. So there is a special tool that has pins that go in these holes to spread the case. Over the years of me working on these, I've never once used a case spreader. They usually pop right out. If they don't, I just take a bar and a block of something soft and just simply pry. If the preload's correct, that was too hard to pull out by hand, but not needing a case spreader. The proper preload on these shouldn't be to the point where you need a case spreader. So once you have it even and straight, it should pop right out. If you're reusing your bearings, make sure you keep the race with the bearing. You don't want to switch sides on those either. So just have your parts laid out nice and organized on the bench as to left and right for the caps and the races. Next thing I'm going to do is remove the pinion. These are a Stover style nut. Some may have a cotter pin. This one is 1 1/8. And just take your impact gun and remove the nut. They do make a yoke holding tool for this, but I found usually just a rag or a glove, or if you have a good impact gun, that'll pop right off. Next up is to remove the pinion and the yoke. If your carrier is still installed, you'll likely need a yoke puller. I'm using a brass hammer. Sometimes they come right off. You can tap them from the back. Obviously this one's powder coated, so I don't want to mess up the powder coating. So what I usually do, most of the time, unless it's really rusty, the pinions will pop right off. So what I'm going to do is reach in here and support the pinion, and then just tap, tap, tap-a-roo. So as you can see, I wasn't hitting that hard, and it came right off. So then you can remove your nut. The nut is just there. It holds the pinion from falling down, and it protects the threads, because you really don't want to. You don't want to mess up the pinion threads. So you can see that's coming right off. There we go. Slide it out. So there's your pinion and bearing. This style, Dana 44, does not use a crush sleeve, so I think that really helps with setup. If you have to take it in and out multiple times, setting the pinion preload, you don't have to worry about the crush sleeve. We're going to set the pinion aside somewhere clean, and we'll check out the condition of this yoke. The majority of your leaks that come from the pinion aren't necessarily from a bad seal. It's usually from a worn yoke. So I cleaned all the goop off of this one, and it looks absolutely beautiful. So what happens is rust and time and a hard seal or dirt will get in there and wear a big groove in this. And then even if you put a brand new seal in it, it either doesn't fit tight enough or the rough, rusty surface will kind of gouge up your brand new seal. So you want to make sure that there's no groove in the pinion yoke itself. This one is perfect. I got it all cleaned up. Anytime you can reuse the original yoke, that's what I recommend. But if you have a bad gouge, some people like speedy sleeves. I'm not a fan of them. I would just buy a new yoke and put it on there. So, but this one's good, and we'll make sure it's good and clean and ready for reassembly. So now we're left with the upper or the outer pinion bearing, and the shims that control the preload are inside here. So we have to remove the seal and take the bearing out, and make sure you don't lose your shims when you do that. There's a couple different ways to get the seal out. Many of you have seen a tool like this. You kind of hook it down in here, and that sounds great, but these usually don't work very well for this style seal. They're usually kind of rusted in there, and they do make, there's several different style seal pullers, but I've found if that puller doesn't work, I just take a screwdriver that I don't care about and bend it inward. You don't want to gouge the seal surface, and you just kind of, you know, misshapen it enough, then you can hook it with the seal puller and remove it. I'm a huge fan of making my videos using tools that most of us will have in our shops. So don't be intimidated by, oh, I don't have this special tool. These are ancient designs. These were made to be worked on by anybody, soldiers out in the field, just regular people in their garage. So I'll just go around being really careful not to damage the housing, bend the flange on that, and then I'll usually pierce it with the screwdriver, put a piece of wood or aluminum there, get it started out, and then it'll pop right out. So you can see I pretty much cut the seal in half with the screwdriver, and now I'm just going to give it a pop. I could see a crack forming in the paint around the seal, so I'm hoping it pops right out. And no damage to the housing. And if you're careful, there's an oil slinger washer down in here. It doesn't even look like we damaged that, but I do replace these. So that's that's the orientation of the slinger washer. And these are really robust seals. They have two ledges on them, so they're pretty stiff. So you really do have to misshapen it and get under it to pop it out. And then there's our outer pinion bearing. As I was working on that seal, these little shims fell out. These go on here, and then the bearing would slide down there. And so what happens, this bearing, it's a very mild press fit. That's why when I tapped the pinion out, it just slid out. So it's not these are pretty easy to get on and off. So what happens as you add or remove shims, it changes the distance between the outer, the inner races. So that's what controls how hard this is to turn. So when we check the pinion preload at the end, if it's too loose, we will remove shims. If it's too tight, we will add shims. So you can see it's a pretty substantial shim pack here, and I want to keep these all together, and I'll clean them up and measure them as a whole to get an idea of what we need to put back in there. So if your pattern's good and your preload's good before you rebuild it, this should get you really close to a good starting point. An important part of this process is just keeping everything organized and together. It's pretty obvious which shims and bearings go where, but it never hurts to take pictures. And as I'm prepping the housing, I'm just going to keep the whole pinion setup together just like that. Obviously we don't need the seal anymore. Another thing you can do is take the slinger washer, although we are going to replace it, put it back on in the exact order it came off. That will just help you if this is your first time or your 21st time, and it might be a couple years since you did it. It will really help you remember the order that this goes in. The next step will be to drive out the outer races. The inner pinion bearing outer race is kind of handy. It has little cutouts in the housing. So I just use, this is a long brass rod, and I just tap one side then the other, work your way down. It has to travel about 3/4 of an inch, and then it'll just pop right out. And there will be shims behind the inner pinion race. That's what controls the pinion depth. So those are super important. So, and they often will get torn up in this process, but that's okay. We'll just measure them individually and get an idea for pinion depth. So just be careful when you're taking them out. The outer race should not have shims behind it. That one is just driven in all the way till it seats. So let's pop those races out, and then we'll pretty much have a bare housing. Okay, so make sure you wear safety glasses, because these chunks of brass or bronze can go flying. So you just had it at an angle using the little notches in the casting. I'm sure there are race drivers, and someone will be like, oh, use a race driver, but I can guarantee you Grandpa was doing it exactly like this. Maybe not even with brass. Some people just use steel since before I was born. So you just alternate just little crisp wax on both sides, and in about 15 seconds it's gonna go flying out the bottom. Maybe like 5 seconds. Once you pop out that inner race, inner pinion outer race, I guess I should say, so it'll look like that. And then this particular one has 3 shims, so these are really important. They go on the back side of this as it's pressed in the housing. These are pretty tight fit, so this is pressed in, or driven in, and then the shims go behind it. So they're very important because this adjusts the pinion depth as to how it fits onto the ring gear. So definitely want to save those and measure them, write it down, and set it aside for later. Roll the axle over the other way and do the exact same thing for the outer pinion race. I need a little bit longer rod to reach down in there, and as I said earlier, there shouldn't be any shims behind this one, so just catch that little ledge. Sometimes it's hard to get, especially if your axle's moving around, and just go from one side to the other. These are moving very nicely. Sometimes they will fight you, and I can say after years of doing this, I've never damaged or cracked a race using this method. I would highly recommend just getting some big long brass punches. I just used 3/4 inch brass round stock. I've found it to be more durable. Just get a bar of it, and then you can cut it into different lengths. Okay, so there's our outer pinion race. This one has a little damage to it. You can see it probably had some water sitting in there, or just years and years of spinning for miles and miles. Okay, so the only thing left in this housing are the outer axle seals. So we'll pop those out next, and then we can get everything cleaned up, and we're ready to reassemble. It's a little hard to see, but behind all this goop is the outer axle seal. It's just a regular style oil seal. These are pressed in from the outside, from right where I am. I usually do these very last so that you don't damage them, and these can be easily changed with the axle in the vehicle. When your carrier's out like mine is, it's kind of nice. You can run a long rod in from the back side and pop them out that way, because given the depth of this seal, it's a little hard to get a seal puller in there, and you have to be really careful. You don't want to mess up this surface. This is a machine surface that fits the outer race of the axle bearing. So for this job, I have a piece of 3/4 inch angle iron. I slid through from this side, and I'm just gonna hit it and pop the seal out. Came out very easy. I didn't have to get too aggressive with it. Just like that. You can see these are toast. It looks like leather. It says USA. It's like old felt and gear oil. So definitely a good time. These are only a couple bucks, and it's not worth putting it all back together with old seals in it. Now I'm going to go over to the other side and do the same thing. I got all the races out. I cleaned everything. It's really important. You want to start with a clean housing. So I flushed this with parts cleaner, blew it out with compressed air, because when I clean this gasket surface, I use a wire wheel, so you want to make sure you don't have any little wire bristles or anything like that in there. Blow out the tubes in both directions and really spray out the pinion oil passageways. And then I just wipe down the races, chase the threads, especially these. They get silicone and rust in them, so I'd like to do that and blow everything out, and we'll be ready for reassembly. Moving on to the carrier, I'm going to replace all the bearings. These look okay, but since we're in here, we're going to just put all new Timken bearings on everything. So we have to remove these. You can take a large split bearing puller and come at it from both sides and pop it off or put it in the press. But doing that, you usually ruin the shims, and I like to either reuse or just at least have a good shim to measure. So I cut the cages off and then pull the inner race off separately. There's several different ways you can do that since we're not reusing any part of the bearing. I just take a screwdriver, give it a little whack, then I come in here with my side cutters. You can use a grinder and cut them off, but then you get grinding dust all over everything, and it's not really necessary. So once you start getting it to kind of bend, you'll get the rollers will pop out, and then you can just be careful you don't cut yourself. Then just spread it like that. So that's just how I do it. I found it's just as fast and effective as using a grinder, but you don't get grinding dust in your locker or spider gears or whatever else you have going on. It's good practice for grip strength as well. Make sure you get all the little rollers out. I mentioned earlier that you don't need any specialty tools for this job. This is one piece of equipment that I would really recommend getting. It's a split bearing puller kit. You can get by without it. You can cut this bearing off, but this is a very quick and effective way. And if you notice, I'm grabbing on the upper lip of the inner race. So when I pull this off, these shims will be unharmed. So this is a good tool to have. You can use it for lots of other jobs on your Jeep, so it's not just a one-time use thing. Boom. And make sure you don't throw out these little guys. So they're really thin, and if there's oil on them, they don't want to let go. You need to get a measurement off these and or reuse them. And make note, this is not the ring gear side. So I label it as ring gear side, not ring gear side. Make sure that they're not stuck to this side as well. They could stick to the carrier or the race. So now we just flip it over, get set up, do the same thing on the other side. So I'm trying to keep this edited short and to the point, but also I don't want you guys thinking there's any tricks or that I'm struggling off camera for hours and then making it look easy, because it's not a hard job. There we go. I've got so that time a shim stuck to the carrier and to the bearing. This side has a little thicker shim, so we have 3, so we'll clean these up and get measurements on them as well. So you'll either want a micrometer like this or just a simple dial caliper to measure all your shims. And so here's just how basic what I'm doing here. So this is the top measurement on the pinion gear. So I have 64 thousandths of shims for pinion preload. I have 28 thousandths of shims for pinion depth. And then down here, so you see the ring gear side is 53. That's what we just took off. And the other side is 29. So I'm keeping those shims together, but also writing it down, and I'm sure you'll enjoy my beautiful artwork. But this will save your bacon when you go to set up your new bearings or gears, just by giving us a good reference point to start from. Now that the carrier is completely prepped and ready for new bearings, let's move on to the pinion. On the pinion, I prefer to use a cutoff wheel to make a little notch, just because the shaft here, you can't get the screwdriver in there as well. So just make a little cut. You just want to be careful not to let the abrasive wheel touch the gear, and then it just pops off just like that. Now I can put my bearing puller on this upper ridge and press the pinion down through. Here's how I have the pinion set up in the press. I'm using a split puller. Notice how I'm spanning the plates like this and not with the bolt side going this way. This is a stronger way to do it. I have a little piece of aluminum so the threads won't get boogered up, and then just reach under and make sure that as the pinion moves that it's not going to hit the side of your press. This is a really small press, but it should be fine here. So once again, if it comes out hard, you can put a little heat on that. Nice and tight here, and wear safety glasses, and then just start putting pressure on it. There, it started moving. These can be on there very tight. That sound is totally normal. Bingo. All the bearings are removed, so now we're ready to start reassembly. Just make sure everything's nice and clean. As I said before, there's no shims here, so the inner pinion bearing can go on right away. That is the easiest part of this job. So we'll press that inner pinion bearing on, and then we'll start putting the races back in the housing. Once your carrier's ready for new bearings, you'd put your shims on and then press the bearings on. So these are a press fit. You'd put them in the press and push them right on. But the problem with that is we don't know for sure that these are the right shims. So these are the ones we took out. We're hoping they're close, but if I press this on here, I then risk either damaging the bearing or the shims, taking it on and off. So what you want to do is have a setup bearings. I'm going to turn that into a setup bearing so that I can slide it on and off as I adjust these shims. So these shims move the carrier, or move the ring gear closer or farther away from the pinion, and that changes the backlash, and it also adjusts the carrier preload. So these are very important, and we'll likely be taking this on and off, adjusting several times, so we need a setup bearing to help with this process. There are companies out there that sell setup bearings, but I've found it's just as effective and much cheaper to just take some material off the inside of this bearing race so that it slides over here. And then you can save these and use them over and over and over again because you're not damaging the cage each time you take it on and off. There's several different ways you can make your setup bearings. I've seen a lot of people use abrasive discs like this or the wider drum type, and they just put them in a grinder or a drill and just run them in and out of the bearing bore. So we're working on this side. I have it held in the chuck of the lathe here, and then all I do is put the lathe on kind of a medium speed, and then I use an abrasive wheel on the drill, and I just run it in and out a few times, checking it every now and then. But you just keep taking little passes until the material is off and it'll slide right on. Alright, so here it is after a few passes, and it slides right on and off. You want a little bit of drag to it. So I don't know if you can see the inside. So that's the inside of the ground down setup bearing versus the inside of the original bearing. The second bearing is done, so we'll test fit it. Slides right on. The next part of this video is going to be a little bonus round. This will be for those who are interested in either replacing their spider gears with new ones, changing to a different spline, or putting a locker in. I have videos specifically on doing the locker, so I'll link them in the description. But I am going to show you how to remove and reinstall spider gears. So you just come over here. Some style 44s have locking tabs. This one does not, so it would just use Loctite. These are 11/16 head on these bolts, and you just remove them. The impact gun is totally acceptable for removal procedures. So you can see some remnants of some thread locker in there. So just pop all of these out. When you're removing them, order doesn't matter and impact is fine, so we'll just pop them all out. Once you have all the bolts out, it's important to mark the orientation of the ring gear. This is cast iron, so you can put a little center punch on the carrier, but a center punch won't work on the ring gear. So I just take an abrasive and just put a little nick in the carrier and a little line on the gear. It's not enough to affect the balance. I'm really just kind of disrupting the finish on that. So then sometimes when you take the last bolt out, the gear will just fall off. Other times you have to tap it off. Always use brass or aluminum. Don't ever hit a gear with a metal hammer. And just like that, it pops off. It's important. So you can see the old thread locker in here. So this has to be very clean. So I'll chase these threads and run a file across this before we reassemble. But for now, I'm just going to put it out of the way. Now we have to remove the cross pin to be able to remove the gears. There's a roll pin that goes down through the carrier. If you've watched any of my locker videos, you've seen this before. So a punch or a piece of drill rod or whatever you can fit down the hole. I like to punch it from this side down, because if you look at the length of this, the pin goes down to there, so we have a much shorter distance to travel down through this direction. So then I'll just take a hammer and just drive the pin through. It's as easy as that. If you got new gears or a locker, they generally come with a new roll pin. I would recommend using that every time. Now it's a simple matter of driving the pin through. So I like to drive towards the roll pin hole so that if there's any burrs on that, I'm not dragging it through the whole case and through the spider gears and washers. So I'm going to drive from this side out, so you can see the drill hole there. I'm just going to tap it through. Each carrier is a little bit different. Some of them you can just push them out once the pin's out. Some of them are quite stubborn. I'm using brass again, and we'll just drive it through the case. You can see now I'm about halfway through. As I was driving it, one of the washers from the side gear or the spider gear fell out. So set these aside. You can reuse them, that's no problem. Once your old pin comes out, there is a spacer in there. Just push that up out of the way. Looks like this, so set that to the side. Then you simply roll the gears around and you should get 2 of these washers, 2 of these gears. And then if you set it up on its side, one of the side gears should come out. It should have this little thrust washer on here, and I don't have enough fingernails to lift. There it goes. So you'll have 2 of these and 2 side gears. Flip it over, drop the other one out. Just make sure you get both washers. There's a washer on every gear. If you just remember it that way, you'll be good to go. For this project, they want to keep this Jeep as close to original as possible. So we're swapping out these 19 spline side gears for a 10 spline side gear kit. So this kit comes with all the washers and gears you need to change the spline count. So these rarely wear out. Sometimes they break if you do a lot of hardcore off-roading or something comes loose inside your differential. So generally it's fine to reuse these, but in this case we're switching to a different spline axle, and we're going to put this fresh new kit in from Kaiser Willys. Reinstalling the new gears is extremely simple. I like to take a little oil or grease. We're going to start with the side gears. As soon as my oil starts to flow, put a nice coating. It's important everything is wiped down totally clean, because you don't want any debris in your shiny new parts. I put oil on both sides of the washer. Then the oil will kind of hold everything in place. And you just drop this little fella right down in there. Do the same thing to both sides. Next up, we put the top gear in, or I guess it'd be the other side gear. I have oil on the washers as well, and just kind of give it a little spin. Should slide right up in there. Depending on the oil or grease you use, it might stay there. Next, we'll take a side gear, so that just dropped down, but it's no big deal. So here's the only part you have to really kind of pay attention on. So put one of the side gears in the opening, try to keep it right in the middle. Just keep pressure inward on that and it'll hold it there. Then you put the other side gear in, and it's really important that they are perfectly 180 degrees out, because if you try to move it it's going to just rock the gear. So if you're one tooth off here, no matter how much you spin the gear, it's always going to be one tooth off. And a quick way to check that is to take either the new shaft or the old shaft and push it all the way through. If you're off a tooth, obviously the really large teeth, it's not going to go through. So by doing that, you know you have them exactly 180 degrees apart. Then you pull it out. I don't put the washers on right here because I find they just fall off. So then you just rotate it over till it lines up with the holes. Then you can take the new washers that came with your kit and slide them into place. So do one and then the other. You can rock it back and forth as needed, but you can easily get both of them in with the gears lined up. Then take your finger or another round tool and line everything up. These shafts go in kind of hard, so you can't just stick the shaft in there to line them up. And the key thing here is to make sure the washer doesn't fall down into the hole. Because if you're driving the pin in and the washer's halfway in the hole, you're hitting it pretty hard to drive it in, and you'll end up with a bent or mangled washer. So that's why I just use my finger, and you can visually check to see that the washers are close. And as we're tapping it through, you'll have to continuously check to make sure the washers stay in place. And I can put a finger in here from this side too, and keep that lined up. The best thing to do is to have another pin or rod that is loose but holds it in place. So this piece of brass is a sloppy fit, but it's close enough that it easily slides through to keep my washer in place, but it doesn't offer resistance. So that will kind of keep everything lined up. You can give it a quick spin to make sure everything's good, and now we can drive the shaft in. You can drive the shaft in from either direction. I'm going to drive it in this way so that I'm not going past that hole, because sometimes you get burrs from the roll pin coming through there. So make sure you have it in the correct orientation. Do your best to line it up. If you notice, the shaft has square flats milled onto it, so you can put a wrench on it and turn it. But I can tell you from experience, the closer to perfect you start the shaft in there, the easier it's going to be. So now I'm using my brass hammer again. I have my little helper rod in there, and I'm just tapping it through. This one's going in quite easy, which is nice. But just remember, we're not quite done yet. So you can see this is my helper pin, and this is the new shaft. Don't forget your spacer block that goes in the center. So you can just drop it down through here. It should fit right through the side gear. It's a little hard to show you. And then you want to make sure that your center pin slides right through there. Sometimes they'll fight you a little bit. There. So now you can see it started through the center pin. These are kind of a loose fit, so it shouldn't be too much of a struggle to get it through there. Give it a little tap. So as you can see, I'm not having to hit this very hard. This is a good time to check and make sure your flat is still parallel to the ring gear surface. That's the way the hole is. And now just tap it through the rest of the way. Here's a good example of what can happen if you don't have a helper pin. So do you see that washer wants to fall in there? So you don't want to strike that pin when that washer is not lined up. So anytime you can do it without having to hit it, you're going to limit the possibility of damaging something. So now I'm to the end. This side, it's getting tight. It's kind of a pressed fit, but I know my washer's in place. So you can see it's not really hard to turn or to hit. So now I'm just looking in the roll pin hole, and I have to use a little helper, and I'm just tapping it until I see that hole line up as close as I can get it. You don't want the roll pin to have to do the work of aligning this pin. So use your hammer. If it's way off, like as in it rolled or turned, then you can tap it back out, turn it with a hammer. You want it to be just about perfect. Final step is to take the roll pin. Your kit will come with a new pin, and I like to drive it in from this side. Again, I'm using a brass hammer. Just make sure you're fully engaging the pin. It should go through the pin, and a portion of the roll pin should be in this side of the casting and this side. So don't just stop it at flush. I drive it probably about a 1/4 inch below the surface. And right there. And now that's not going anywhere. Once you've got it all together, you can give it that nice satisfying spin. This inner spacer floats. It's got an oblong hole and it will slide around. So when you put your axles in there, that'll flatten it out, square it up, and center it in that hole. Just for reference, that's my old spacer. So it has a lot of movement. So don't worry about that. I know it looks a little crooked in there, but it'll move around and find where it needs to be. The next step is to install the ring gear. It's very important that you get all the thread locking compound out of the holes and off the hardware. So then I spray brake clean and compressed air in each hole, and make sure you have no burrs or dings. If you do, touch them with the file. Same way for the carrier. Make sure it's completely clean. This corner and edge really need to be checked to make sure there's no oil or grit or anything in there. And if you remember, we did mark the gear with our little line there, and I have a mark on the carrier. It's really important you get it as close as possible right as you're dropping it down on, and make sure that it's nice and flat. If you put it down on an angle, it's going to get stuck. So like we said earlier, some of the ring gears will just fall off. This one is held on tight enough that it doesn't just fall off. You want it to be absolutely perfect before you put the bolts in. If they don't easily start by hand, then it's not good enough. You do not want to use the bolts to line it up. You'll end up damaging something. So it should start by hand without much force. I start every single one of them by hand before I put thread locker on it. Some will say this is unneeded, but if you can't start all of them by hand easily like this, then you don't have it lined up correctly. And on a gear that fits loose, it's not a big deal, but some of these will be really snug, and you'll end up not having it aligned correctly, and you might strip out the bolt or damage the gear, and you just don't want that. If you have a locking tab style setup, then you don't need any thread locking compound. You would just tighten these down and bend the tabs over. If you have a non-locking tab style hardware and carrier, then you'll need to use some type of thread locking compound. I'm really partial to the Loctite stick. It's kind of like chapstick. I found it's easier to work with, and it doesn't run off. And I put a liberal amount because you don't want these loosening up and damaging anything. So just prep all your hardware before you start. If you're doing a locker or re-gear kit, it might come with this style. That's fine as well. So this is just the personal choice of which type of thread locking compound you prefer. We've got thread lock on all the bolts, and once again I'm starting each and every one of them by hand to make sure they all go down nice and smooth. Now I'm just using an impact gun to save time. I'm not really making it tight with this. I'm alternating in a star pattern. So I'm probably putting maybe 10 or 12 foot-pounds on them just to save time. Now we're going to do the final torque on these. I have it in the vise with a rag. You'll need something to hold this. So get a buddy. If you have a big vise, you can throw it in there. It's not I'm not cranking on it. It's not super tight. It's just enough to hold it. You could step it up and do, 30, 40, whatever, but I haven't found that to be necessary. Once you get two of them snugged up across from each other, the ring gear is going to be where it needs to be. So there's our first click. Consult the service manual for the vehicle that you're working on. This particular one is 55 foot-pounds. So as I said before, you don't want these bad boys loosening up on you. Okay, that's it. This carrier is done. It's ready for shims and test bearings. I'm set up in the press, ready to press on the new inner pinion bearing. For this, I'm not using a test bearing. This one goes on and stays on, and there are no shims in here, so we're not really worried about making sure we can take it back off. So this is pretty simple. This is the first one I usually put on. So no shims here. You can heat that bearing a little bit if you want to, but they usually press right on, no problem. I'm using an old bearing race that I know fits on the inner race only, so that you should be able to spin this the whole time you're pressing this on. And I have a little hunk of aluminum on the nose of the press, and you're just going to press this all the way down. So notice this still spins, that way I know I'm not hurting anything. And make sure your plates are set up with a big enough hole that the little shoulder on the pinion gear slides down through, because you don't want that catching the edge of your plate. So some of these smaller notches aren't big enough for this job. It's going to make some creaks and some pops, and that's okay. So you can kind of hear a sound change there, so I know I'm all the way down. Race still spins nice and smooth. That's it. Moving over to the housing, our next step is going to be to drive in the outer pinion race. Okay, that's this little guy, and this is not a test bearing. This is the final bearing. This is a Timken. Make sure your housing is nice and clean. It'll drop right in until it gets to the portion of the housing where the press fit begins. So now I'm going to use a brass rod. There are seal drivers that you can use. I've had no issue just using my little trusty brass rod, just like you would a wheel bearing and a hub. Just tap it alternating sides and it'll go right in. The thick flat edge goes down. It's really important that you get it started straight and square in the hole. And now I'm just going to take my brass and start with little taps. It's a little hard when the differential's out of the vehicle like this, but just nice and even, and it doesn't go in super hard. So I like to just pick, I don't usually go all the way around, just one side and then the other, and making good progress. You'll hear a sound change with a loud thud right there. That side's down, that side's down. You can run your fingernail on the inside and just visually confirm it. So that's it. That's all it takes to get that outer race in. And now that side is done. Up next, I'm going to install the same shims that I took out. It was 28 thousandths in this case, but yours will likely be different. They just drop down in there. Now I have a test bearing. So this is the outer race that has been stoned down on the outside, just like on the carrier. And this is really going to make your life easier. That drops right in there, squishes those pinion shims, but does not require it to be driven out. So it just slides right in there. It's extra money and extra work, but trust me, it's well worth it. Next step, I'm going to take a little, you can use a heavy oil. You could use gear oil, but I just don't like getting it all over myself and smelling it. So I'm just using some AMSOIL assembly lube. Just get a little bit on that bearing. Let it kind of run down in there, and then just carefully support it, drop it in, give it a little spin. Oh yeah, that's nice. Next up is to install the outer pinion shims. This is the same thickness of the stack that I took out, and you'll just slide them over there, make sure it goes all the way back to the little ridge. And then I have another test bearing. So this one I stoned the inside, and that allows me to check the bearing or pinion bearing preload without having to drive this through. This is the one test bearing I think you can get away without using, because it's very easy to tap this through even without a test bearing. So, but this is gonna make it just a little bit easier, so you can see I can push this pinion right out with no problem. I have the outer test bearing on the pinion. Then you're going to install the oil slinger washer, and then the pinion yoke. Sometimes they go on a little stiff. Then take a washer, and now here's another test piece. So this is a test nut that I just made by running a tap through a stock locking nut, and then crank it down. So it needs to be tightened to roughly what it would be all assembled. So I can tell right now that this is a little loose. So that means for final assembly, I'll start removing some of the shims behind that bearing. But this is fine for setup purposes. This doesn't affect the pinion depth, only the pinion preload. Back over to the bench. Now I'm going to consult my notebook, and we're going to install the shims on the carrier for our initial test. So I know on the non-ring gear side, that would be this side, that I should have a shim pack of 29 thousandths. So that's this one. And then I'm going to slide one of my lovely test bearings down on there. We'll put a little bit of oil on that too before we stick it in. Flip it over and confirm my shim pack. I'm looking for 53 thousandths. That's this stack. Put that on. Make sure the bearings are nice and clean. Pop that on. So now it's super nice. If I need to adjust it, I can just pull the carrier out, pop the bearing off, change the shims, and throw it back in. Next up, slide your outer races over the test bearings. Try not to cut off your fingers setting this down in. Just as when it came out, it needs to go down in nice and even. It's totally fine to use a rubber hammer. You might have to reach down here and turn the pinion to make sure it's lining up. I can tell by the way that's going in that the preload is correct. So that means the overall shim and bearing width is pretty much perfect. That's how I like them to go in. That's exactly what came out. These bearings are new, so they might be a little bit more proud than the other ones. So I will have to pry this back up, but it's giving us a more accurate read of what we're looking for final preload. We'll keep that same overall measurement. We'll just be shifting this back and forth. And I can tell by feeling that I would say our backlash is going to be a little bit tight, but we can adjust that by moving the ring gear away from the pinion. Once the carrier is dropped in, just set your caps on, reference your picture or where you had them laid out on your shop floor, and make sure they go back in the same orientation. Always start them by hand. Anytime we're working on the differential or anything important on an engine, everything should go nice and easy by hand. And I'm not using a torque wrench, just run them down snug. And it's always exciting when you do the first turn by hand, and I can tell you right now this feels really nice. Put a little oil or grease on those bearings and it spins good. So we'll check the backlash and then run a pattern and see what we get. To check the backlash, you're going to need a magnetic base dial indicator, and you want to come out to the edge of one of the teeth on the ring gear. It's best to be as close to in line with that as you can be, and you're going to secure the pinion and rock the ring gear back and forth. There should be a small like tunk, 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 or like click, 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 and I could tell from setting this up. So the needle's moving there, but that's just because I'm not able to hold the pinion sturdy enough. but I would say there's somewhere in the ballpark of maybe 1,000. So, and you can kind of get a feel for it just after you've done it a few times. But I can tell right now we're going to need more backlash, but we'll check the pattern anyway. So that will mean we need to move the ring gear that way, a little bit away from the pinion, and that'll give us a better backlash. It should be like 7 to 14 thousandths. I'm going to try to hit around 10, 8 or 10, somewhere in there. So we're too tight on that right now, but that's okay. I'm going to run a pattern, just get a good idea of where we're at, and go from there. Just like we did in the beginning of the video, we're going to put a little mustard on the gears, except we're going to try to be a little more tighty than they were originally. That was all over everything. This stuff is like anti-seize. It likes to make a big mess. As I mentioned earlier, less is more with the gear marking compound, because if we have to do this 6 or 7 times, you're going to end up with mustard everywhere. So I'm putting the impact gun or drill back on. Got my leather glove. You have to have resistance on this. It can be hard by yourself when it's in the vehicle, but the glove and the drill makes it so much easier than turning it by hand. Now the other direction. Again, it's important to get lots of resistance on this. It's kind of hard for me to get you in there real close, but this is a pretty darn good pattern for the first run, especially setting up used gears. You never know. They kind of already get a pattern worked in, and you're just trying to get close to that. These gears are used, but they looked really good. So there's the coast side. And then if we roll it over here, you can see the drive side. The drive side is a little bit towards the heel, but it's really not bad at all. And sometimes you'll chase it around, you'll move a little bit, and it comes over here and it's too far. So that's actually really darn good. So I think what we're going to do now is get the backlash correct, because I don't think we really need to move too much on the actual like pinion depth. It looks really nice. So I'm gonna pull the carrier out. We'll move some shims from this side to that side, moving the ring gear away from the pinion, and then we'll check it again. I got the carrier back in. All I did was take the smallest shim out of this side. I think it was 7 thousandths, and I put it over there. And now you have to hold the pinion perfectly still to be able to read this. So we're just looking for the needle swing without moving the pinion. So I'm trying to get it to a solid number there. So now I'm just rocking the ring gear back and forth. If you push too hard, you'll move the pinion, because we don't have a lot of pinion preload. So that's why a little bit more pinion preload would make this job easier. But and it's jumping around on me. I'm right around 10 thousandths of backlash, which is perfectly good for me. I got the gears painted back up, and we're gonna run a hopefully final pattern now that we have the backlash set correctly. So I got my trusty old glove out and give her a couple spins. It's a little bit hard for you to see, I'm sure, but adjusting that backlash really brought the pattern in even better. So now it's confined more towards the center of the tooth on both sides. So I consider that personally just right. So this is going to be a nice smooth running rear axle for a very long time. Now all that's left to do is pull the carrier out. We're going to take off the setup bearings and put on the new bearings, set the pinion preload, and this thing's done. I know the first time I did this, I was searching for, I look at the timestamp on the YouTube videos, and I'm like, where's the 5-minute video? I want to do this quick. This is a very long video, and I really don't think that you can effectively show this procedure in a 5 to 7 minute video. So if you're still watching this, that probably means you want to do it right. And unfortunately, this is one of those jobs. I find it very satisfying, but it takes some time. Before we install the carrier bearings, we need to set the pinion preload a little bit tighter. So you have to remove the nut and then pull the yoke off. Reach from behind. I'm going to pull the pinion all the way out. Try not to lose your bearing. And to make the pinion preload tighter, we'll remove a shim. If it's too tight, you would add a shim. So I'm going to start by just removing one of the very thin shims. Since we have a setup bearing, this is very easy. I'm not even going to measure it because I know it needs to go a little bit tighter. And then stick the pinion back through. Pinion bearings in there. Slinger washer. Yoke. Washer. Nut. It gets very repetitive, but by the end of this process, you will be a pro. For this step, you will need a beam style torque wrench that reads in inch-pounds, because you're checking not what it takes to get it moving, but what it takes to consistently move it. And we're looking somewhere around 15 inch-pounds, and we are not there yet. Alright, I removed about 10 thousandths total of shims, and now I'm getting about 20 inch-pounds as it's rotating on the beam, and I'm totally happy with that. It's nice and smooth, but there's enough drag there that I know it's got enough preload. Now that we have everything set and ready to go, we'll remove this setup inner race. Now we'll install a brand new Timken outer race for the inner pinion bearing. I install these the same way. I'll just use my brass rod, alternating sides, and tap it down in. It's the exact same procedure as the outer one. I'm just tapping back and forth with a brass rod. Once you get it straight, it's just a matter of walking it down in there. This one's a little more tricky because you don't have much of a area to strike, but you'll get it. There you have it. So you can see, depending on how many shims you have, mine came out almost flush with the top of the housing, so it wasn't too hard to drive in. I put a little assembly lube on there. Before I did that, I flipped the housing up and gave it another shot of parts cleaner and then some compressed air, because the brass rod, as you're hitting the sharp edge, will leave some little flecks of brass. They probably wouldn't hurt anything, but brand new bearings, we want to keep them nice and clean. Next up is to install the outer pinion shims, and you'll just slide them over there. Make sure it goes all the way back to the little ridge. To install the new front pinion bearing, it's the same way that we installed the test bearing. Push your pinion in nice and snug. Slide that bearing in. Slide your oil slinger washer in. Put the yoke on. You should be getting really good at doing this now. And snug it up. Okay, so we know everything's good now. We already checked the pinion preload multiple times, so now we're going to remove the yoke and install the seal. You probably have had the yoke on and off enough times by now that the splines are nice and clean and it all comes off. So now we're ready to install the seal. One thing I do want to mention is that you always want to check, after you get rid of the test race and the test bearing, recheck your pinion preload before you put the seal in. So as I just want to stress, the seal is the very last thing to go in, because if you have to change the pinion preload shims, you will destroy the seal and you'll have to put another one in. So it's not the end of the world, but it'll save you 15 bucks. So I'm just putting my torque wrench back on here. If it's tight, because the bearings can differ a little bit, especially if you're using different brands, so we're still good. You want to be in that 10 to 20 inch-pounds. I like to go, with new bearings, I like to be around 15 to 20 inch-pounds. So you kind of get the feel for the drag on it, because the new bearings will set in more than old bearings will. So that's just something to keep in mind to help you prevent you from having to buy another pinion seal. Now that everything's done, our final step is to install the pinion seal. Make sure your oil slinger washer is installed. This is my absolute favorite pinion seal for these Spicer axles. It's an original Spicer part. Really high quality seal. Fits perfect, goes in nice, and then if you need to remove it, these also are more pleasant to remove compared to some of the other seal designs. One thing I really like about the Spicer seal is that the inner lip comes packed with grease, so you really don't have to worry about putting lubricant on these. It's just a really nice designed seal. It is a spring style seal as opposed to some of the older solid seals. I just think these just hold up better. I've had these in all my Jeeps for many years, and it really gives you a leak-free and easy to install seal. Make sure your seal surface is totally free from debris and isn't marred up. You know, if you have to take a little file, if someone else has gotten ugly with a seal removal tool, you might have little dings or dents in this. If you have big dents or gouges, you can fill them with JB Weld, let them dry, and then sand them smooth. Otherwise, just check and file as needed. I like to put a little bit of silicone on the splines and wipe a little bit on the yoke as well. If you have a paper gasket you'd like to use, I haven't found them necessary, but I have one and it's definitely not going to hurt anything. I put a little thin layer of black RVT all the way around. I use ultra black Permatex. I don't think that's necessary either, but it definitely doesn't hurt. So oil slinger washer is in there. Got the seal and the paper gasket. I don't really use a seal driver for these. I think they go in so nice on their own. Just a little hammer, equal taps, making sure you keep it nice and flat. Most of the oil leaks I find on transfer cases and differentials are simply because someone hammered on the seal so bad. Like if you put a socket on this inner lip, there's nothing to support it there, and you're going to bend it out of round, and then you're going to have an oval shaped opening, and that's not going to work. So that's it. It's in. It goes in till it's flush with the outer housing. You don't have to go any farther than that. Then I just take a rag, wipe off any excess silicone. A lot of people say that doesn't do anything. They might be right, but it does act as a little bit of a lubricant, and then any little imperfections in your housing are going to be sealed up. Last step is to install the yoke. You can definitely put a little grease or oil on the seal surface. Like I said, this seal has oil on it. And just slide that in there. Remember, on final assembly, we're not using the test nut. This is the actual locking nut because we're done at this point, and then snug it up. This gets torqued to 200 foot-pounds, so you'll either need a yoke holding tool, or I usually wait until the axle's in the vehicle and the wheels are on. You can have someone hold on the brakes and get a big breaker bar, snug it up, and then finish it off with a torque wrench. If your seal's incorrect, it should spin, have the exact same preload. When you're setting up the gears, you always check the preload with no seal, because it can provide a little bit of drag, but it shouldn't make it significantly harder. There are certain style seals that you'll punch in there and you'll tighten this up, and then suddenly you can't move it at all, and that probably means you either have the wrong seal or your seal isn't in far enough. And I can say from personal experience, I've never once had that issue with the Spicer style seal. They fit perfect, and they're always good. Now I'm jumping back over to the bench with the carrier. So I like to do one side at a time. We're removing the setup bearings and shims, setting them off to the side. It's important we don't mix them up, so I have everything written down so I know exactly which bearing or which shims go where. So we'll remove the setup bearing. Make sure you get all the shims, they like to stick. Set that to the side, and we're going to focus on one side at a time. Nothing like opening a fresh Timken box from Kaiser Willys. This is the real deal, no more setup bearing, and that's going to get pressed on just like that. So do make sure you don't put them on backwards. I've seen some carriers with the bearings on like that. It's a big no-no. So we're going to set it up in the press and smush on this guy. I'm using a plate of aluminum on top. For this, you don't have to use a bearing race or any spacer. You can go flat right across the top. Make sure your carrier is centered in your press as best you can, and just start pressing it on. The key here is that you just make sure it's on nice and straight, and hopefully you have your shims in place because we're moving now. Notice how the outer race still turns freely. And just push it down until it's tight against the carrier. Now we flip it over. Ooh, look at that pattern. Good stuff. Ugh. Set it back in the press. Don't forget your shims. New Timken bearing. Set it on as square as you can get it. Put our plate back on top. It's a good idea to make sure your lower race spins as well, and press it on. Now just repeating the same procedure on the other side. Shims are in place. Send the bearing all the way down. I like that little squish when you hear the shims come together, making sure both races aren't getting crushed. And we're done. This carrier is ready to go in. We got the new outer races. Remember, we're completely done with the test bearings now. Got some lube on the rollers and slide it down in there. It might be a little more snug now. Ooh, that feels good. Oh yeah, feels good. You can look at the edges once there's no gap on both sides. Looks good. Impact gun just to snug them up. Not final torque. Now it's time to torque the carrier caps. These get torqued to 80 foot-pounds. It's a 3/4 inch socket. Done. The final step to wrap up this part of the axle rebuild process is to install the axle seal. So this is what separates the gear oil inside the differential from the bearing. The bearings on this axle are lubricated by grease only, so you want to seal them off from the gear oil. If you remember in the beginning, this was all full of grossness and we popped these seals out. So now we're just going to simply drive them back in. The most important thing is that it's back far enough to clear the wheel bearing and that it's flat. That's the critical part, because if your seal's in there kind of wonky, it's not a true circle and it won't seal correctly on the axle, because that axle is going to be spinning in here the whole time or anytime you're moving the vehicle. So it needs to be back onto that flat machined surface and nice and flat. I keep a variety of tools on hand for installing seals. This is a seal install tool for a front axle. It has two different sizes on it. Sometimes that's handy. Has a flat end on the other side. And then just a good old set of sockets work as well. This isn't rocket science. Any kind of seal driving tool will work just fine. And as I said, the most important thing is that you get it started in there nice and straight. So I found that tool gets it started. And then I just put a socket. You always want to use the biggest socket you can. These don't press in super hard. Looks pretty good. One thing I do is take my dial caliper and set it up just to see. You can go on the inner ridge too. And then just run it around and you can really quickly tell if you have it in flat or not. So once it's in, You know, I'm probably an 1/8 of an inch into the machined surface, and it's nice and flat. Means we're good to go. For this project, I also installed a brand new drain plug and differential gasket from Kaiser Willys. This is also an important part of your axle project that's often overlooked. This is a vent. It allows expansion of air as the fluid gets warmer. It allows that to come out, but prevents water and other debris from getting in. So that brings this axle right back to where it was when we started as far as the level of disassembly that I received it in. So it is powder coated, all new bearings, all new seals. This thing is ready to go. Anytime you have questions, please feel free to put them in the comments or call Kaiser Willys. The guys down there will be happy to help you as far as finding parts or looking into what you need for your project. The video coming after this will be installing wheel bearings on the axle shafts and kind of getting this axle buttoned up a little bit more before we ship it back to South Carolina, and Mike and Jason will put this under the 3B. So as always, thanks for watching. Catch you later.